Space is cold, colder than any winter night on Earth, colder than anything we can naturally experience. But how cold is cold, really? And is there a limit to how cold things can get? When we think of space, we often imagine distant stars, exploding supernovae, and blazing suns. But in between all that light is a vast ocean of cold, quiet emptiness. And somewhere, hidden among this darkness, lies the coldest place in the known universe. But here's the twist. That place isn't just out there in deep space. It might also be in a laboratory right here on Earth. To understand where and why, we need to dive deep into the limits of physics, the behavior of atoms, and the eerie world of quantum science. Let's take a journey through some of the coldest corners of existence and discover what extreme cold teaches us about the very nature of reality. At the heart of cold lies a simple idea. Temperature is just the measure of how fast particles are moving. The warmer something is, the more its atoms bounce, jiggle, and collide. So imagine a temperature so low that all motion completely stops. No vibrations, no collisions, just stillness. That's absolute zero. 0 Kelvin, or about minus 273.15 degrees Celsius. It's the coldest theoretical temperature possible, the point where a system has no thermal energy at all. But there's a catch. Even in the coldest parts of the universe, absolute zero is unreachable. A faint afterglow from the Big Bang, called the cosmic microwave background, bathes all of space at a steady 2.7 Kelvin. It's like the universe's built-in heating system, preventing the vacuum of space from ever getting truly still. If absolute zero is impossible, then what's the coldest natural place we've found? The answer lies 5,000 light-years away in the constellation Centaurus, inside the hauntingly beautiful Boomerang Nebula. This object is a dying star, shedding its outer layers in a furious storm of expanding gas. As the gas rushes outward at over 600,000 kilometers per hour, it rapidly cools. And thanks to this extreme expansion, the Boomerang Nebula reaches a staggering temperature of just 1 Kelvin. That's colder than the rest of the universe. It's a kind of cosmic air conditioner, cooling itself faster than the cosmic background can warm it. And it's the only naturally occurring place we know of that has dropped below the temperature of empty space. Incredibly, the coldest temperatures ever recorded didn't happen in space, but in a laboratory on Earth. Using powerful magnetic traps and finely tuned laser beams, scientists have cooled tiny clouds of atoms to within a billionth of a degree of absolute zero. At those temperatures, something astonishing happens. The atoms stop behaving like individuals and begin acting as a single quantum entity, a new state of matter called a Bose-Einstein Condensate. This ultra-cold material behaves more like a wave than a collection of particles. It's one of the strangest and most beautiful phenomena in all of physics. In this man-made cold, we're not just learning about temperature, we're exploring the quantum structure of reality. And it shows us that cold isn't just about absence of heat. It's about unlocking new realms of physical behavior we can't see any other way. So, could we ever reach absolute zero? Could we go beyond it? According to the laws of physics, the answer is no. Absolute zero represents a fundamental limit. It's not just cold, it's the complete absence of thermal motion. You can get close, infinitely close, but you can never remove all the energy from a system. Temperature isn't like a number you can force downward forever. It's tied to motion, to energy, to entropy. Going colder than absolute zero would mean making particles move less than not at all, which doesn't make sense. It would violate thermodynamics and break the foundations of how we understand heat, motion, and time itself. It's a cosmic barrier, one we can only ever approach but never cross. From the emptiest stretches of space to the heart of a dying nebula, and even inside Earth's most advanced laboratories, we've traveled to the coldest realms known to science. In these extremes, matter begins to behave differently. The rules of classical physics fade, and the strange world of quantum mechanics takes over. Chasing the cold isn't just about numbers on a thermometer, it's about pushing the boundaries of knowledge. The closer we get to absolute zero, the closer we get to absolute truth. Thanks for watching. If you enjoyed this video, don't forget to like, comment, and subscribe. There's so much more to explore together. Stay curious, and we'll see you in the next adventure.